Hi everyone, I'm James White from Illmatic Energy, and I'm going to be talking to you about the ORE INFOMAR review I carried out on behalf of these fine organisations. Have any of you ever listened to the BBC podcast, 13 Minutes to the Moon? It's a podcast that details the Apollo missions in the 1960s and how they went about putting a man on the moon. I was listening to this whilst compiling this report, and I could draw parallels between what they were trying to achieve in the US in the 1960s and what we are trying to achieve in Ireland with the ORE sector now. Back then, in 1961, JFK announced that the US will commit itself to achieving the goal before the decade is out of landing a man on the moon.
To go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win.
Yes, that's a very famous speech from Rice University, and was JFK's rallying call to the American people to get behind the space program at the time, which seemed like a farcical idea back in the 1960s to land a human on the moon. But what is of note there in that speech is that it's going to be hard, it's going to be difficult, but with the collective energies and skills of everyone, they can make it happen before the decade is out. And that's where the parallels start. It's because in the Programme for Government 2020, we have committed to generating 5 gigawatts of renewable power offshore by 2030, so also within the decade. In 1966, Apollo 1 was constructed and completed. So what's of note here is that there's quite a large gap, or perceived gap, between what JFK said in 1961 and what happened in 1966. And again, that's parallels with what's going on now. There's not a lot of turbines offshore at the moment, but a lot of groundwork is going on behind the scenes. And then in 1969, the Apollo 11 mission, Neil Armstrong walks on the moon, probably the most famous thing in the 20th century. And what you can see there is that in a short space of time, between 1966 and 1969, a period of 3 years, there was rapid acceleration within the space program. And several space missions took place before finally achieving their goal of landing a man on the moon in 1969. And I believe it'll be similar here, where we won't see much happening in the development side until the end of the decade, and then there'll be a rapid evolution of the ORE sector in Ireland. 30 years after Neil Armstrong walked on the moon, Ireland began its own voyage of discovery with the Irish National Seabed Survey, which was a precursor to the INFOMAR programme. And in 2021, we're hoping that the MPDM bill could provide a launchpad for the ORE sectoral development in Ireland. That'll be 60 years after JFK's initial speech. In 2026, it is envisaged that the seabed mapping programme will be complete, and INFOMAR Phase 2 will have completed the entire mapping of the Irish offshore. That'll be also 60 years since the Apollo 1 mission completed. And in 2029, 60 years after Neil Armstrong walks on the moon, wouldn't it be nice if we could land our own goals and have the 5 gigawatts of power ready to come on stream for 2030? I started off talking about 13 minutes to the moon, and now I'm going to leave you with 13 more minutes of Zoom. I know you all are pretty fatigued at this stage of Zoom calls and webinars, etc. So I'll try and keep it as informative and exciting as possible. One last thing though, it's worth noting that even NASA had some geophysical equipment with them up on that Apollo 11 mission. They brought a seismometer with them to measure the subsurface of the moon. And on to the INFOMAR programme. What has that got to do with space? Well, as you've seen previously, NASA thought it was worthwhile recording what was beneath the surface, and so do we. You can see here a variety of beautiful pictures from the INFOMAR survey. In the bottom left-hand corner, there's a beautiful image of a wreck, the SS Polwell. We also see some nice sediment waves in the Irish Sea. But as well as nice pictures, the INFOMAR program is also of huge benefit to the ORE industry. In the maps in the middle of the slide here, you can see the bathymetry dataset as stands. This dataset is an excellent dataset acquired to international hydrographic standards. It is envisaged that it will be completed by 2026. There is some data gaps that you can note on the map, but these should be filled in by the time the survey is complete. Also acquired along with the bathymetry data is the backscatter data. What is backscatter, you might ask? Backscatter is when different seafloor types return the acoustic signal with different levels of energy. The different values in intensity, or scatter, are used to examine the nature of the seafloor in a backscatter chart. Now, this is just a relative property and not quantified. Therefore, sometimes what gives you a hard signal may just be sand that has got some cement through it or is more finely grained than the previously recorded in other parts of the seabed. On to the shallow seismic and sub-bottom profile data. This is the most important data set for the ORE industry. What is it? Well, you've probably heard these different terminologies being thrown out. Pinger, chirper, sparker. And no, they're not bars from the 1990s. They are different acoustic measurements and different arrays which offer different penetrations through the seabed and subsurface. What you can see here on the left-hand side is pinger, chirper, and sparker, and they're different frequencies and they're different rates of penetration through the seabed, with pinger being the shallowest and sparker being the deepest. Sparker is of the most benefit as it gives the deepest penetration beneath the seabed. However, it's also the most infrequent in the INFOMAR dataset. The INFOMAR dataset's data quality is also variable, ranging from poor quality to good quality, as you can see in the images. Even in the good quality images, you can see the seafloor multiple, which is prevalent beneath it. And on the right-hand side, I've got an image from the Dogger Bank in the UK, where even there, with high quality shallow seismic data, we struggle with the seafloor reflector. The sub-bottom data set has evolved over time, as one would expect, with poorer quality data set at the start of the INFOMAR program, with better quality in the subsequent years. It is also a function of what the subsurface is beneath it. But there is times that even with what is perceived as poor quality data, you can enhance it through processing and reprocessing. This is a case study from Dundalk Bay. This is the initial input, and this is after some initial processing by Doug down under GeoSolutions, who offered to look at this data set and offer some geophysical solutions to it. And what you can see here is quite a prevalent seabed multiple. For those of you who don't know what a seabed multiple is, it is basically a repeat of the signature of the seafloor bottom, but it's not the primary signal. Therefore, it should be removed and can lead to errors in the subsurface interpretation. And here we go with the seafloor multiple removed. And all that is left now is the geology that lies underneath. Let's have a zoom in and see that again. This was the data set after initial processing. And what you can note here is there's a problem with statics on the seabed reflector. What are statics? Statics is that jittery, noisy looking substance that you can see, which makes things hard to decipher and see. Also, amplitude preservation and noise is an issue. Once we apply more sophisticated processing techniques, we can enhance this data set. Here we see it. I'm just going to flick over and back between the two. Before and after, it's like night and day, foggy, unfoggy, and allows for a much more detailed geological interpretation. Here we can see channel fill, older channel fill, a large channel cut, overbank deposits, and possible slumping, all of which will have different sediment properties and different settlement rates, which you will need to know about if you are planning to build a wind farm in this area. Data integration is key when unlocking both the INFOMAR products and any other relevant sources of information. We talked before about a lot of the geophysical products that INFOMAR acquire. However, it is necessary to calibrate these with hard data. CPTs and cores are essential for getting the soil and rock properties for the seafloor and what lies beneath. The Geological Survey of Ireland also offers additional information which may be of relevance to the ORE sector. Here is a geological map of Ireland with the faults overlain on top of it. You can see a variety of lithologies, and when you overlay the river systems on top of this, you can see what lithologies are being eroded into your area of interest, as that has implications of what sediment is on the seabed and what sediment also is under the seabed. The Petroleum Affairs Division also holds a wealth of information from the oil and gas industry. Hundreds of millions of euros was spent on these data sets, and they would be of huge benefit to the ORE sector. You can see the complete data set overlaying here on top of the bathymetry from INFOMAR. This is a section which shows the seismic line from PAD overlaying with the insert from a sub-bottom profile data. And what you can see here is that the seismic line, or deep seismic line, is showing a lot more geological information which is of benefit to the ORE sector. It gives you a better understanding of what is going on, particularly of faults that go to the seabed and of potential shallow gas. Also, some of these 3D datasets offer the opportunity to really bring out some beautiful features on the seabed as the image below. And what you will find in many occasions is that the features you see on the seabed are directly linked to the tectonics which underlie them. On the bottom right-hand corner is the final result which we are aiming for, an integrated 3D ground model, which will happen when we integrate all available data sources together. So where are we? Currently in Ireland, we produce 25 megawatts offshore arc flow. So there's quite a gap between that and the 5 gigawatts the government want generated by 2030. On the top left-hand side, you can see a map showing some of the foreshore license applications in the Irish Sea. It is envisaged that the ORE development will happen in a staged approach. First in the Irish Sea, followed by the Celtic Sea, and then finally into the Atlantic. Technology is evolving all the time in the ORE industry, as demonstrated here in this diagram, as turbines have the ability to move further and further offshore. This is important, particularly if we want to move to the Atlantic coast. Recently, Simply Blue Energy announced the Western Star project. This innovative project will look at a combination of floating wind and wave energy to produce electricity on the west coast of Ireland. Many of these projects will need green hydrogen to reach an export market, as grid infrastructure alone will not be enough. Green hydrogen can be produced when water is split between oxygen and hydrogen by an electrolyzer. This may happen onshore, or as technology advances, even offshore. There are other emerging technologies such as tidal, wave, geothermal, and CCS, but unfortunately, we don't have the time to discuss these in any detail in this presentation. The evolution of the ORE sector in Ireland. The INFOMAR datasets will continue to provide an essential toolkit for supporting Ireland's ORE sectoral development in Ireland. In particular, site selection, seabed infrastructure, and landfall. Data integration and calibration are key components of this. Policymakers, capital providers, and industry need to work together to ensure that everyone is pulling in the same direction to achieve the common goal of reaching the 2030 targets. Grid infrastructure will need to evolve for the government targets to be met. If Ireland aspires to be a net exporter of clean energy, larger interconnectors will have to be constructed to the UK and Europe. Building the supply chain is an important factor that needs to be considered when scaling up. The UK market divided into 8 infrastructure hubs for the ORE industry. Ireland has several potential infrastructure hubs and needs a strategic plan if it is to avoid using the UK as a supply base. Intermittency and storage remain key concerns for renewable energy. A combination of floating offshore wind and green hydrogen could pave the way for ORE hubs to be established on the South and Atlantic coasts, providing much needed employment in socio-economic disadvantaged areas. And finally, the Marine Area Planning Bill could be the catalyst which enables the evolution of the ORE sector in Ireland. This one small step could provide a giant leap for the industry. I hope you've enjoyed listening. This has been a very high-level presentation. For more details, please download the report, and if you have any queries, please get in contact.